And welcome to Module 3 of TECM 5191. Today we're going to be talking about modular content, and more specifically, this lecture will describe how content is treated as modular, so just sort of at a conceptual level. It'll introduce topic-based authoring, we'll define it and look at some examples. It will explain structured authoring, we'll also define that and look at some examples. And then finally, we'll close the lecture with exploring macro-level content modeling. So let's get started. So what is modular content? So modular content is essentially a different way of thinking about content. Traditionally, we think about content in sort of neat packages, right? So a book, for example, would be a collection of content that's all sort of in this finite package of a book. On the other hand, modular content is content that is much smaller pieces of content and serves a specific function. In the Module 2 reading, the Module 2 materials, I asked you to watch a video presentation by Daniel Ferguson, and he talked about the idea of single sourcing, right? So this idea of having one source of content outputted to multiple places and multiple mediums. And the way that we accomplish single sourcing is through modular content. Now, modular content has a variety of labels or nomenclature to describe what a module is. And some common terms you might run into are modules. A second one you might run into is granules. And a third one you might run into is topics. Topic is actually the preferred nomenclature in Madcap Flare, also in the DITA library framework. And so instead of thinking of content as a page or a chapter even, or a document even, we want to start to shift our thinking into thinking about modular content as topics. And we'll talk about that more here in a few minutes. Before we move on, I wanted to quickly remind us of this study that I mentioned in Module 1. And basically, this study surveyed technical communicators and asked them what their primary, secondary, and tertiary authoring software was. And you'll notice DITA, FrameMaker, and Flare, all three of these are all XML frameworked authoring tools. And all three of them use modular content, modularized content. Now the difference, again, if we start to shift our thinking away from content as an article or as a book or as a chapter of a book, and we start to think of them as topics, instead of our content being housed in this sort of finite place, like a book, it's actually housed in what a database that's referred to as a knowledge base. Often referred to as a knowledge base. And so again, we've got the shift in our thinking away from sort of finite finite pieces of content that are sort of more static, and we want to shift our thinking into more dynamic pieces of content that are stored in knowledge bases. Just to clarify some terminology, there's a variety of types of systems for managing content. There's ECMSs, Enterprise Content Management Systems. These are typically going to be like intranets, things like Microsoft SharePoint that businesses will use to keep things private, to share files, to share things with one another. The second row you see here is content management systems. And this is typically referring to web content, right? So content management systems manage content that's specifically outputted on the web. And these are going to be, some examples of these are WordPress and Drupal. We've talked about WordPress in the past. Now, the most important is going to be the third row here are component content management systems, or CCMSs. And these are content management systems that are specifically for specialized modular content. These are almost exclusively used by technical communicators. And these are things that all are, these are pieces of software that are all sort of built on the XML framework. These are things like AEM, EasyData, XDocs, Oxygen, or Flare. In this class, we'll use Flare, and we'll talk about sort of some of the limitations and benefits of Flare later in this presentation. Now, when we think about content and we think about content strategy, really that can mean a lot of different things to different people. And if you've taken the content strategy course, you're probably well familiar with this and with the distinction between sort of marketing communication and technical communication. But one thing I want to point out, so as you see here on the left, we've got what's called traditionally was called a sales funnel. It's also referred to as a customer journey now, but essentially it's this idea of how do businesses or organizations get customers into and actually finally purchasing their product. And typically technical communicators, we typically enter the conversation after a product is purchased, right? So if someone purchases a piece of software, they might see a quick start guide or they might see a manual on how to use that piece of software. And that's where technical communicators typically live. On the other side of the spectrum is marketing communicators. And in Marcom, they typically are working at the beginning of the sales cycle or the customer journey, right? So they're working to help people become more aware of the actual product itself. And one of the things that that I want to point out is just the way that we think about content strategy is actually quite different. And one of the shifts that you're seeing in technical communication is TECM folks being integrated into being integrated into the sales funnel or the customer journey much earlier. So just wanted to point that out to clarify the difference between TECM and Marcom. Now, what is a topic, right? So there are different definitions for what a topic is. And even within TECM, there are sort of competing philosophies on how to define a topic. So, for example, Mark Baker in his book, Every Page is Page One, would argue that, for example, an entire recipe is a topic. One recipe equals one topic. So Baker would argue topics should allow a user to complete a concrete task. And so Baker would argue, this entire recipe is one topic. So how to make lasagna or the world's best lasagna is a topic. DITA, on the other hand, which stands for Darwin Information Type Architecture, and in DITA, they would argue that we could break this recipe, for example, down to multiple topics. So, for example, the recipe's ingredients could be a reference topic, while the step-by-step information on how to actually complete or bake the lasagna would be a task topic. So, as we can see, there's different philosophies on how to break up a topic, and it's less important to choose one or the other, and more important to understand that topics are smaller chunks of content that can serve multiple purposes and multiple functions. Now, what are some of the downsides of topic-based authoring? Well, Mark Baker, in his 2012 book, called poorly executed topic-based content Frankenbooks, right? So these are books that are sort of Frankenstein together with multiple voices, multiple authors, multiple perspectives, and maybe even overlapping content. And the reason why Frankenbooks happen or are one of the downsides to topic-based authoring is that when technical writers and technical communicators go to actually write in a topic-based format, in a lot of cases, they're not given enough structure or rules on how to write a particular topic. And so that's what we want to talk about next, which is structured authoring. Okay, so we'll move on to the third part of our lecture, and we're going to talk about structured authoring. And to define structured authoring really quick, Anderson and Batova, two technical communication researchers, defined it as content that's written and organized in a consistent way according to a set of predefined rules. And the takeaway here is predefined rules. Now, there's a variety of ways to create these rules. We can make them up ourselves, or we can use a pre-existing libraries like DITA. But the fact of the matter is that the pre-existing rules provide us with a variety of advantages. Let's take a look at a couple examples of what maybe some structured content might look like. So this would be for a recipe for pizza. And you'll notice the tags are in XML. They look quite similar to HTML. The primary difference is that HTML tags are structural in nature, meaning like a paragraph tag describes paragraphs, or a list tag describes lists. It describes the structure of the content. In XML, including DITA, our tags are going to be semantic, meaning instead of a paragraph tag, we are looking at a recipe tag. So we know automatically this is for a recipe. So every recipe has to have a name, and recipes have to have ingredients. And so what's interesting is the main structure of this particular example is every ingredient needs to have an item, a quantity, before it can be deemed a full ingredient. So it has sort of a structure along with it. So what are the advantages of structured authoring? Well, there's three main advantages, and the first is writers need less training and oversight from editors, right? So one of the huge advantages of structured authoring is the tags itself, the structure itself of the article sort of narrows the ability to sort of go outside of the structure. So for example, if we just had an ingredient tag, for example, writers might interpret that ingredient tag in different ways, right? Some might include the item, some might not include the quantity, some might include the item and the quantity, and maybe even more additional information like the preferred brand for a particular ingredient, for example. Now, if we were to leave topic-based authoring to a group of writers without any sort of predefined set of rules, without any structure, you might get articles that look and sound wildly different. But in this case, we know, every ingredient needs an item, every ingredient needs a quantity, and it's much easier for writers to follow that structure. Secondly, formatting content is totally separate from creating it, meaning we could output this content in a million different ways, and we can make it look and feel however we want it to look and feel using CSS, right? And so because we're using structured content, we could, for example, style or design all of our ingredients in the same way, right? We could put them in a bulleted list, for example, or we could style the name of our recipes all identically. And we could use these elements or these tags to target in CSS and make sure that everything looks and feels consistent. Thirdly, we can actually create content that's much more easily searchable and findable for users because we've got a variety of tags and we've got a variety of data related to tags, so metadata. So for example, if we wanted to just look for pizza recipes, well, we'd be able to do that using this structure. Or if we wanted to just look for recipes by the author Chris, we will also be able to do that. We could even dig deeper into the structure and say, I want only to find recipes that use mozzarella cheese. Or if we had more information or more metadata for ingredients, maybe we say, I want only ingredients that use or I want recipes that only use organic ingredients, for example. So there's a variety of ways and advantages to structuring our articles. Now, if all of our topics weren't the same structure, these advantages go away, right? So we wouldn't be able to search for things as easily because some of them might have quantity, some of them might have organic label or not. And so then we've got a variety of data that's inconsistent, and therefore when we're returning data to our end users, we can't do it quite as consistently unless we have this structure on top of our topics. So how is content structured? Well, there's a variety of ways to structure content. You can come up with your own rules. That's one way of doing it. Or you can use industry standards or best practices. The most commonly used sort of structure is what's called DITA, or Darwin Information Typing Architecture. And this is essentially a set of predefined rules that work with XML. And DITA has their content model really divides things into three different types of topics. And the reason for this is DITA was created specifically for technical content. So they have task topics, reference topics, and concept topics. So what I want to do now is I want to walk us through an example that comes from an organization called Jorsic, or a company called Jorsic that produces a piece of software called EasyDita. It's an authoring software very similar to Flare or any other XML-based authoring software. And so Jorsic came up with a set of rules for their writers, and I wanted to kind of walk through some of those rules that they have put on for their particular in-house writers. So we'll walk through each of the three tasks, references, and concepts. And the first one we'll start with is tasks, because that's the easiest one to wrap our heads around. So tasks, and Jorsic defines tasks as articles or topics that describe how to do something. So how do I do X? That's sort of how you define a task. You'll also notice that each of these tasks have in here in bold different structured elements that must be included in a task. You'll also notice that there's guidelines for each of these structured elements, right? So it's not just good enough to just have, every task topic should have a short description. There's also guidelines, right? So describe it in less than 50 words. The easiest way to sort of see this applied is in the title, right? So for topic types, we want to use gerund verbs or verbs ending in ing. And that's just to keep task topics consistent, right? So toasting bread as opposed to like how to toast bread or the best way to toast bread. If we use or follow the guidelines, all of the task topics are going to be similarly titled. For concepts, Jorsic says to their writers, concept topics should answer the question, what is X? So for example, in this case, Toaster Classic. What is Toaster Classic? And you'll notice, again, we've got elements that are required in all concept topics. And we've got guidelines for each of those elements. And then finally, you can see in references a similar pattern. We've got elements that are required, and we've got guidelines, and then we've got the end example. Typically, references in DITA are going to be in the form of tables. It's usually things like specifications, ingredient lists, etc. Okay, so we've just walked through three examples of DITA topic types. These are concepts, references, and tasks. And of those three, we walked through guidelines from Jorsic that Jorsic provided to their content writers. And these guidelines are just sort of parameters for each of the different structured elements within a topic. So let me give you an example. In our reference topic, the elements are title, short description, reference body, section, table, and example. Some of them are optional, some of them are not optional. But you'll notice that in DITA, these elements themselves are typically defined using DITA XML. So actually using the markup language of DITA. Flare can't do that, right? So Flare has some limitations. So it's actually kind of a good thing because you're not going to have to actually write markup. We can actually use Flare's software to kind of circumvent having to write markup. So essentially, what we can't do in Flare is we can't create or edit DITA files directly. And DITA files are just actual files with the file extension .dita. So these are specific DITA files that contain DITA XML. What you can do in Flare is you can import or export DITA files. So if you've got existing DITA files, you can import them, you can work on them, and you can export them again as DITA files. You're not going to have to worry about this this semester. You can also follow guidelines for titles and other elements. The main way we can do that is simply by using brackets. I showed you that in the week 3 or module 3 overview in the example template that I showed you. You can add titles and short descriptions and topic properties. And then most importantly, number 4 here, you can create templates for topic types. Okay, so one of the things you're going to be asked to do as a team is to create a content model, and part of that content model is going to include 3 templates: one for tasks, one for concepts, and one for references. And the big question you're probably having is, well, how do we actually define elements? And again, a reminder: elements, just things like title, short description, etc. How do we define those elements without using TECM? Well, I kind of briefly touched on this in the Module 3 overview video, but essentially you'll select, for example, the heading or the title. Let's say you select the title in Madcap Flare. You'll right-click the title, and you'll select the name menu, and you can name that element anything you want to name it. So the example I'm showing here are sort of second level elements. So the result, for example, steps or prerequisites, I've named these elements. So instead of using DITA XML to describe these elements, we can just actually name them in Madcap Flare itself. Okay. So the next section and the last section of this lecture will talk about macro level content modeling and micro level content modeling. So let's start with macro level content modeling. And content modeling is essentially just how are we modeling, how are we putting together and organizing all of the content, the whole universe of content. How are we organizing that? That's essentially what content modeling is doing. So typically, if we look at our hardware guide, so again, one of the things you're going to have to do is you're going to have to work through the Zen 4 content from the hardware guide and the software configuration guide. You can kind of think of a macro level content model as sort of the original PDF, right? So the original PDF had its own content model, and it's sort of limited to excuse me, it's sort of limited to the medium of print, right? So a print PDF is sort of a finite document. You can't really add any sort of dynamic content to it. And so that's one example of a macro level content model. Well, what you're going to do is you're going to take the existing content and you're going to perform a information architecture on the content. And that what I'm describing here and I'm walking through here is going to be that team content model assignment that we'll do at the end of the week. Okay. So for that assignment, I've already given you a spreadsheet with all of the content inventory. So every article that exists in the Zen 4 content library. Okay. So that's going to be all provided to you via Madcap Flare and via Madcap Central. You should be able to follow along the overview video along with the assignment where you're asked to access the content, the Zen 4 content, and that should provide all of the instructions on how to do that. So we're giving you essentially a list of every article in the entire Zen 4 library. Just as a quick overview, every article is divided by whenever a new H1 tag starts in the PDF. Madcap Flare automatically created an article. The way you can find these H1 tags are the easiest way to find the way that these articles are broken up is to look at the actual table of contents from the PDF itself. So if we look at Chapter 1, which is what we're going to be using for our proof of concept, we can see things like software components, and then we can see that there's a topic in Flare called software_components.htm, and you can see where it is. It's in content and it's in hardware install. So I can safely say, this particular article corresponds with this software components article in the PDF. So that's important. So the first thing you'll do is the content audit. So you'll see here in red, you're going to do the content audit for every single article in the content inventory. Okay. That would be a total of 196. So 195 articles. So you'll have to go through 195 articles, and you'll have to decide: is this a concept, a task, or a reference? Right? It sounds like a lot, but it shouldn't. It shouldn't take you that long. You just access the article and decide: is this a concept, a topic, or a reference? Okay, so that's this second step of the content audit. Our third step would be information grouping, and in information grouping, what I want you to do is to first look at the way that the content is currently grouped. So right now, we've got a chapter 1, Introduction to the Tech Company Servers, and then we've got level 1 headings, or level 1 sort of architecture, technical overview, for example, and then we've got level 2. Articles like system management under the technical overview. So that's sort of the existing grouping architecture. So the first thing I'll ask you to do is, does it make sense for the existing grouping architecture to keep the existing grouping architecture? The answer might be yes, or the answer might be no. It might be better to name these something else, or it might be better to move one of these topics into a different category, or any number of things we could do. And so what you'll do on the actual spreadsheet itself is, in column G, you're just deciding the actual article. So again, our same example, software components. How is this grouped? Where should this go? And so for this, I've chosen chapter 1, hardware. If I were to choose something like system management, for example, I might include chapter 1 under technical overview, or chapter 1/technical overview, just to give a sort of a clear understanding of how and where this particular article should be grouped. Okay. Step 3 will only be completed on the content that you'll be using for the proof of concept. So step 2, you're going through all 196 articles or topics. Step 3, you're only going through chapter 1 of the hardware guide, chapter 1 of the software guide, and appendix A of the software guide, appendix B of the hardware guide. Okay. That's all in the assignment description. I understand that it's a little confusing when I say it fast like that. Make sure you're looking at the assignment description. Again, how are you finding, out of the 196 articles, how are we finding these different topics? The main mechanism for doing that is going to be the table of contents. So look at the table of contents, for example, processors, memory, and partition, and then look for that corresponding article. Look for that corresponding article in the spreadsheet. Okay. So that is step 3. Steps 4 and 5 are taxonomy and metadata creation. So that would be columns E and F. So again, and these are only for the proof of concept files. So again, chapter 1 of hardware, chapter 1 of software, appendix A of software, appendix B of hardware. And what we're doing here is we're just including keywords that we want to include in the article. So I chose software, component, and operating system, and then any metadata, which is, so your keywords are going to be your preferred keywords, the ones that we're essentially naming the main ways of finding this particular article. And then metadata will be sort of your secondary keywords, other words that are associated with the article. Maybe they're terms that are found in the article that could be linked to other articles, for example. But in this example, I chose CLI, which stands for Command Line Interface, GUI, Graphical User Interface, and ZVisor, which is another one of their pieces of software. So you can kind of see I've provided just one example. You're going to do this for all of the files that are in your proof of concept. Okay, so just wanted to walk you through that. Last thing I wanted to walk you through before we end this lecture is I've added 3 new capabilities of what Flare can do. So we can identify and tag keywords. That's as simple as literally highlighting a word, right-clicking, and tagging it as a keyword. We can add hidden text and headings. That's somewhere where we might include our metadata, for example. We might include, references to ZVisor, for example, in the heading as hidden text. And we can also set up search engines and micro content. So, for example, Google short blurbs that you see, those are usually fed by content from the website. We can actually tell Google, use this micro content or this snippet for search engine for when the search engine returns a result. We won't have to be doing a ton of that this semester, but certainly identifying 4, 5, and 6 here, creating templates, identifying and tagging keywords, and adding hidden text to headings are activities that we will end up doing. But for this stage of the game, all I'm asking you to do is to complete the content model as a team. So you'll turn in the spreadsheet, and the other thing you'll be asked to do is, again, create those 3 templates, one for concept, one for task, and one for reference. As always, do not hesitate to email with any questions. Speak to you soon.